Here's our example number 4 with the series circuit. So we look at our circuit, we follow the wire out of the battery. There's only one path for current to flow, so that's a series circuit. And what we're trying to figure out is how many amps are flowing in this circuit. So to figure that out, what we need to do is we need to write down our known values. So 12 volts. And we don't know what our amperage is, and we can figure out what our resistance is. So that's R1 is 2 ohms, R2 is 2 ohms, and R3 is 2 ohms. Okay, so now this is actually a pretty easy equation to do, because all we really need to do is apply our circuit laws and Ohm's law to figure out the rest. So we know that in a series circuit, resistance is additive. So 2, 4, 6, that gives us 6 ohms of resistance. So we have 6 ohms of resistance total. And so now we can figure out what our amperage is pretty easily, because voltage divided by resistance gives us amperage. So 12 divided by 6 is 2. So if we figure, we can fill in the rest of the blanks pretty easily by applying the circuit laws, and then that way we can double check and make sure we did it right. So in a series circuit, amperage is constant. So this is going to be 2 amps, this is going to be 2 amps, this is going to be 2 amps. And now it's just a matter of doing Ohm's law to see if everything works out. So 2 times 2 is 4 volts, 2 times 2 is 4 volts, and the same thing up here, 4 volts. So now all we have to do is just double check ourselves. 4 plus 4 plus 4 equals 12. Amperage is constant. 2 plus 2 plus 2 equals 6. And so I know these are really simple. You could do this all in your head, and there are simpler ways to do it. I like to do it this way simply because when we get into more complex circuits, this kind of helps map it out for you. So that's why I was wanting to do these with the simpler circuits, just so that you get the process down. So when we get into the more complex circuits, it's a little bit easier to calculate those.